Okay, to extend this a little bit further, so what we're saying is that 1 over c squared has an important relationship with mu naught and epsilon naught. So the vacuum permeability and the vacuum permittivity of space. Okay, so all of a sudden 1 over c squared has a relationship to c squared in terms of inversion, and c squared has a relationship to the diameter of the helium Bose-Einstein condensate, the singularity at the beginning of time. And that relates to the way space operates, the vacuum of space. Okay, so what's happening within that dimension is of interest. And how did I get to Einstein c squared? Well, we know that E equals mc squared in terms of the mass energy equivalent equation, and that has a relationship with c squared. Okay, so we then know the relationship with 1 over c squared with epsilon naught mu naught. So 1 over epsilon naught and mu naught equals c squared. So the inversion is important. The inversion is a process which is involved in this entanglement. Tunneling and entanglement involves inversion. And we can take the c squared equals E divided by m, which is the rearrangement of the mass equivalent equation that Einstein and others had presented back in the 1900s. And we can relate that to 1 over mu naught epsilon naught. And the right-hand rule of electromagnetism, the electric field on the cross, E and M being at 90 degrees to each other. At 45 degrees, there's an electric or a photon emitted, right? It's that interaction between the electric and the magnetic. And in that kind of geometry of s orbitals, if we consider M to be positrons and E to be electrons, we have an electric field and a magnetic field. The magnetic field is a positron carrier. Positrons and magnetic field. There's potentially a link there that others have also recognized. So what I'm saying is, well, this E divided by M is only one quadrant. There's also E divided by negative M and negative E divided by M and negative E divided by negative M in the 4 regions of that cross-based geometry. So there's more to it. There's more to it. We've been missing 75% in terms of that light field. There's both inward, where the negative M and positive E are attracted because they're of opposite charge. There is the negative E and the positive M, which is attractive, of positive opposites attract. M positive, E negative, M negative, E positive. But we also have repulsion of E positive, M positive, and E negative, M negative. So repulsion means expansion. Attraction means contraction. So there's both an inward and an outward. So in this model, it really conveys a balance of opposites operating. And then in 4, right? So what do I mean by in 4? Well, if you consider each of those positions, an E, an M, a negative E, and a negative M, there's 4 positions there. And if that relates to the electron and the positron in terms of the s orbital structure of hydrogen in the single atom system that I'm suggesting with the revised quark charge calculations, then you can relate the positioning of positron and electron in terms of the electromagnetic interaction. So what I'm suggesting is that the electromagnetic photon fields can be aligned with the positron-electron positionings in s orbitals. When they are aligned, then you can consider both the wave and the particle. The wave-like properties allow quantum tunneling because the electromagnetic wave has no mass and no charge. In that sense, tunneling and movement can be determined by wavelength. And then the positron and electron are shifted by the wavelength of the electromagnetic component of the s orbital. And we know Fraunhofer spectral lines. We know that there is a way of looking at electron transitions based on the photoelectric effect that Einstein put forward in 1905, or whenever it was. And so we have a way of going, well, rather than looking at atoms from the positron and electron perspective, can we look at atoms based on the Fraunhofer line electron transitions, the spectral lines associated with an atom? Can that give us a framework that would assist in understanding the landscape at an atomic scale that can be operating? I'll leave it at there, but I'll talk and kind of highlight a couple of other aspects of this atomic relativity landscape that I'm building. Thank you.